Okay, welcome back from your weekend. 2.3, day 2, we'll be finishing up section 2.3 today. Today we're going to be working on using the remainder theorem and the factor theorem to find zeros. Okay, and it's a big process, so it looks like just one learning target. There's a lot to it, okay? There is something I noticed from last week, this worksheet, as I was checking in the assignments, that I needed some feedback. So check all the solutions. I posted them online. But this one in particular, a lot of us thought this was factorable. And so you tried to factor it when it's not factorable. You got to slow down in this process. Remember, you're looking for factors of -8, but they have to have a sum of the middle term of 6. Your factors of -8, your only possibilities are 2 -4, -2 +4, or 1 -8, and vice versa. So look at these sums. 2 plus a -4 is -2. -2 plus 4, +2. This is going to be -7, and then if I flipped it around, +7. None of them have a sum of 6, and a lot of you push forward with these thinking it was factorable. So slow down, okay, if it's not factorable. I know in the notes all of them were factorable, so I don't know if that threw you off, but sometimes your notes don't prepare you for all scenarios. You got to react with your other skills. So if a quadratic isn't factorable, like always, since Algebra 2, we have to use the quad formula. Okay, or unless the square root method's an option. And it wasn't. So quad formula, which we've probably done 15, 20 times now, you know how to do it. But just wanted to talk about that real quick. Make sure you don't factor it unless it is indeed factorable. Okay? All right, so you can check the rest online. It's on there. Let's go ahead and get going here at 2.3. All right, so here's where we left off. We need to start with the remainder theorem. Okay, what the remainder theorem says is when we divide by a factor, x minus k, then our remainder is found by just taking k and plugging it in. Okay, basically it's a quick and easy way to find the remainder. So for example, if I compared it to number 8 here, 4 is the k value, right, for this problem, right? Because it's x minus 4, so we call the k value 4. If I just plug that into the function, evaluate it, it automatically gives me 984. It gives me the remainder right away, even if it's 0. So the k value for 7 was -1. If we take that -1, plug it into the function, it's going to give me 0 right away. Okay, and then we know it's a factor. Okay, so this is a way. Here, why don't you write this down kind of in layman's terms to quickly find the remainder just plug in, I'll put k in quotes, plugging in k into the function. Okay, so that's how we quickly get the remainder. It's basically a shortcut. If you want to find the remainder and find out if it's actually a factor or not, because here it wasn't a factor. If something has a remainder of 0, means we call it a factor, right? Make sure you're following along here, right? 10 divided by 3 has a remainder, right? This is 3 1/3. So we say 3 is not a factor of 10. But 10 divided by 5 is 2, remainder 0. When you have a remainder of 0, we call it a factor. Okay, so that's sometimes how the remainder theorem can help you quickly see if it's a factor or not. Okay, so let's take a look at these directions. Use the remainder theorem and synthetic division to find each function's value. Verify your answers using another method. These are actually 2 different methods as it is. I'm not going to have you use a third method. 2 is good enough. Okay. All right, so here's our function. They kind of already gave us this form where they put the k value here. So it's like we're dividing by x minus 2. So you might want to make note of that here. I wish they kind of did it the other way around. They said if you divide it by x minus 2, find the remainder, but this is the way they do it. So this number right here, this is k. So x minus k, or x minus 2, is our divisor. All right. Okay. So let's just start with synthetic division. We're going to use synthetic division to find the remainder. Okay, so we put our k value up in the corner box, and then the coefficients: 2, -8, 10, -7. Add going down, multiply going up. Keep going. Okay, so we get -3. This is our remainder, right? Okay, so we know how to find the remainder like that from the last lesson. So here's how we do the remainder theorems. There's two parts to this, right? Synthetic division, check, done. Remainder theorem, I'll just separate these processes here with a line. And I'll title this remainder theorem. You should do the same, so when you look back at your notes, you know that this is a little different. And the remainder theorem says we just need to plug in 2 into the function, the k value, whatever it is, whatever's in this corner box, and then get your answer. Okay, so you guys know how to plug things in the calculator, plug it in for each x. I'm not going to write that down. It ends up giving us -3 as well. But that's how you confirm it. If these numbers aren't matching up, you either messed up plugging it in or you messed up your synthetic division. So check both and figure out where you made a mistake. Okay, so this means we have a remainder of -3. Okay, pause. You try it here. I don't care which one you do first. Okay, synthetic division and remainder theorem. Like I said, you can skip the third method. Okay, here's your solutions. So now the k value is -2, meaning really our divisor is x plus 2. So x plus 2 is the divisor. That's what we're dividing it by. We go through, actually worked out the remainder of 0. If you plugged it in the calculator right, we also got 0, which means x plus 2 is a factor. Okay. All right, so let's go ahead and turn the page. Take a look at the next one. Okay, so for these particular problems and their process, these are going to take some practice. Okay, the end result is to find all the solutions of the equation. Here's the problem with just trying to factor this one. You don't have to write this down. This is just something that I wrote down just to show you. If we're to try to factor this by grouping, I took out the x squared. Here I could only take out a -1. It's not factorable. This should be in common if it's going to be factorable. Okay, so now what? That's why they're taking us through a little different process. There is a way we can still find the zeros by using synthetic division. Okay, so let's talk about this factor theorem again, then talk about these steps. We used the factor theorem in 2.2. Let me remind you when we used it. I told you if k is a 0, which is what they're saying here, if k is a 0, then x minus k is a factor. Okay, we used that here because we had zeros like -3. On that worksheet that was due last week, you did problems like this. And so since -3 was a 0, we could write factors. Okay, and then we multiplied it out. So we've already used the factor theorem. It's going to come up again in 2.2. Okay. All right. So let's go ahead and go through these steps. Write down the success criteria. I jammed it in here. If you want to run it along the top, it might be better. First step is we're going to divide the function using synthetic division. Okay. Using the x value that they give us, because they said x is a solution. So 3 is a solution. That's a 0. Step 2, we're going to use that result to rewrite the function. Okay, so write this down. If a over b equals c, then c times b equals a. Okay. All right, so what that means, it's really just a basic division algorithm. What I'm trying to say here is if, for example, we know 12 divided by 4 equals 3. Okay? So when you take a division algorithm like that, we can also rewrite this using multiplication. Since we know that result is 3, can't we also say that 3 times what I divided by, 4, equals what I started with, 12. Okay? And that's going to be important. We can use that for polynomial functions as well. Once we divide it, we get an answer. We can take that answer, multiply by what we divided by to break down the function and rewrite it. Okay? Once we get through that critical step, we'll just use our skills to find the remaining zeros. Okay. All right, so here we go. Step one. They do give us the fact that x is a 0 or a solution. So, using the factor theorem, we know that if f of 3 is a 0, then x minus 3 must be a factor, or is a factor. So we're going to use that to our advantage to kind of break this function down. So divide the function by x minus 3 for step 1. So we put the k value, or 0, in the corner box. 2, -3, -11, and 6. Okay, we don't have to use long division when it's in the form x minus k, right? So add the 2, add going down, multiply going up. So this is going to give me 6. Add 3 times 3, I end up with 9. Add to get -2, multiply -6, and 0 for the remainder, which we shouldn't be surprised by that because we know that this is supposed to be a factor if 3 is a 0. Okay, so remember underneath here, if you need this help again, this is always the remainder. This is the constant term, or x to the 0, x to the first, and x squared. Okay, or 2x squared plus 3x minus 2. Okay. Okay, so now this allows us to rewrite the function. This is an important concept for you to understand. Okay, I go back to this real basic algorithm right here. 12 was divided by 3. I'm sorry, divided by 4. The answer was 3. So now we can rewrite 12 as 3 times 4. So this function was just divided by x minus 3, and this was the result. So now I can write this times x minus 3 equals that. All right, so here, let's just try to make this very, very clear. Step 2, we're going to rewrite the function. Okay, so you don't have to do this every time, but I'm going to do at least the first time. I'm just going to rewrite that first function that we started with. But now I have a new way to represent that. Just like we do 12, we can break it down to 3 times 4. Now I can rewrite this as x minus 3 times this result, 2x squared plus 3x minus 2. Okay, I hope that makes sense to you. If it doesn't, I just have to repeat this, right, over and over again. We can rewrite a division algorithm by the multiplication of what you divided by and the results. Okay. All right, so now from here, we can go ahead and continue to use the result to continue to try to factor this and then get all solutions. Okay, so are there factors in -4 that add up to 3? There are. So I'm going to kind of go off to the side and brainstorm that. So factors in -4 that have a sum of 3. Maybe you brainstorm this a little bit differently. This is a good way to organize it though. All right, so I'm thinking 4 times -1 pops in my head. Gives me a sum of 3. Okay, I got it right away. So remember, I take these factors, siphon it through here to split up the middle term to 4x minus 1x. Okay, I'm not really doing anything with the x minus 3. Okay, I'm just leaving it there for now. We're focusing on this quadratic part. All right, I can factor out the GCF out of both of these groups. So this is going to be a 2x. So x plus 2 to get that. And here I'm going to take out a -1. And this, I'm going to get x plus 2. Okay, and this is in common. X plus 2 can come out of both. So now I get x plus 2. And then when I take that out, I'm left with 2x minus 1 as my other factor. All right, so now I have the factors of this 2x squared term. The x minus 3 I'll bring back in here. Okay, so now I basically took this term. We used synthetic division to break it down one step into these factors, and then we kept going. So now I have this factored completely. I can't really go any farther. And now we can go ahead and find all our zeros by setting each of these individually equal to 0. If you need to do that, excuse me. If you need to do that off to the side, go ahead. but this is pretty easy to do the mental math on this, right? So our zeros are, here we get positive 3, which was given.